So just a quick note before we get into it. There's been, just to make sure this is clear, apparently some of you didn't get this on day one, but posting code publicly on Piazza or Discord, this is not allowed, obviously. It's obviously cheating. We're going to start, if we got to start the meetings this early in the semester, that's what's got to happen. Just going to have to call you in, give you an F in the course. It's obviously not acceptable. I don't know how anybody thinks that's okay. Don't post your code publicly on Piazza. You're not allowed to let any student in the class see your code. How posting it to the entire class all at once, where everybody can see it? How do you think that's okay in any regard? So obviously that's not okay. Some students have not gotten the point. We're going to have to start handing out the Fs if it continues. Just stop doing that. Come on, what are you thinking? Anyway, let's get into it. Objects and classes. And the lecture question, the one we want to get into today, what we'll be able to do is write a Scala class that has some internal state that when the methods are called, that internal state is going to update. And then when other methods are called, we can access that internal state to be able to read what happened through the previous calls of these methods, of the objects that are created through a class. So there's a bit going on. So we're going to build a vote counter that takes votes that are part of the input some possible options as strings. Then whenever you get a vote for a particular string, whenever you get a number of votes, so somebody's reporting, okay, I got 1,000 votes for this option, add those votes to that option, and then get votes. If somebody tries to get the votes for a valid option, return the total number of votes that have been collected through the add votes method. And if the option is not a valid, if the input is not a valid option, return 0. If you looked at this question ahead of time, I didn't have this last line. I didn't have a condition for if it's not a valid option. You should return 0 if the asked for votes is not a valid option. And then, of course, the testing. How do we test this? We have a class. How do we test a class? And for that, we're going to create new instances of that class, create those objects in modified state and access that state. So what does any of that mean? Let's talk about it. Because a lot of those words shouldn't make too much sense as of right now. So let's go through these and talk about what objects and classes are, starting with objects. Objects we've played with already. We've written objects for each one of your lecture questions. You've created an object with some methods. And we wrote those methods to have some functionality. And we haven't gotten into it much, but these objects can also have state. So an object is a way to package variables and functions together in one object, in one container that we call an object. Those variables we'll see today, and then those functions that are part of that object, we call them methods when they're part of an object. We don't call them functions anymore. So objects contain functions is actually incorrect. We call them methods when they're part of an object. So objects have state and behavior. State through its variables and behavior through its methods. And we have these state and behavior in one package, one container that we call an object. So we haven't seen objects with variables, so let's do that now. If we have an object with some state, we're going to have variables that are outside of all of the methods of that object. Any code that we have, any variables we have outside of every method is part of the state of the object. And that state can be accessed by every method and is shared by every method in the object, and can also be accessed by other code outside of this object, by other objects can access these variables. So we have this object, we have standard, what we've been seeing all semester, some object containing some method, but now outside of the method we have these variables x and y. This is going to be the state of that object. Now we have for example, double x, this method, returns unit, doesn't return anything. So why would we ever have a method that doesn't return anything? What's the point of that? It's because this method is intended to modify the internal state of the object. So we call double x, it doesn't return anything, but we can modify the state of this object And now when we call other methods down the line, then those other methods will have different behavior because they can depend on that state. They can do something different based on that state. This thing always frustrates me all semester. So we have the state and behavior. Whenever we want to access a variable that's part of the state of an object, we can use the keyword this to signify that we're accessing the state of this object. The keyword this dot, is usually optional-ish, but I highly recommend leaving it there to make it clear to anyone reading your code that you're modifying the state of the variable or you're accessing the state of the variable. Because this can have some dire consequences. If you're calling a method that modifies the state and you're not aware that it's modifying the state, it can be tough for other developers to know what's going on when that happens. In this method, this is what we call a method with side effects. We're not calling this method to return anything. We're calling this method to modify the internal state or has some side effect. Similar to the print line method, we call that for its side effect. And here, we mentioned this earlier in the class, but if we have variables declared with var, worth repeating this, with var, these variables can change the value they contain, that they store, and then val cannot change. That's a value. It stores that one value for its entire lifetime, and it cannot change after that. If we try to change a value of the value stored in a value, we get an error. We can't run our code. That code will not compile. It will not run. So when we have these state variables, when we have these variables that are part of the state of the object, these have many different names. I'll tend to call them state variables in this class because I want to motivate the state pattern that we're talking about later, and I want to make that connection. But these have many different names. If you've worked with classes and objects before, you've heard at least one of these names, most likely. Instance variables, member variables, fields, and state variables what I'll use. Each one of these is referring to the same thing. It means we're talking about some state of an object, some variable that's part of that object's state. So all these can be used interchangeably, but I'll stick with state variables. If you're reading documentation and they say fields or instance variables, member variables I think are a little less common to be called that, but fields or instance variables, these are the same thing. And there's some other names, some other nomenclature other people like to use. But they all refer to the same thing. And any code with access to the object has access to these state variables. So we have some other code in a different object, another method in another object that has a reference to this object with state. It has access to its state and behavior. It can call its methods, it can access its state. So we'd say object with state, as long as this object is imported into this project or in the same package, so it doesn't have to be imported. As long as it has access to that object, it can modify its state. It can access anything about it with that reference. And every value in Scala is an object. I'll repeat that once we come back to the slides. So if we have this object, this one. If we have this object with state, we could try to run this object, but nothing happens. It doesn't have a main method, so we can't run it. But we can either write a main method in this, or what I did here, write a main method in another class. And here's part of that code that we had in the slides. I'm going to write a main method that's going to access that object in another file, defined in another file. I'm going to access its state, object with state.x, so give me the value stored in x of this object, which is going to be 10. I'm going to call double x from outside of that object. That's going to multiply x by 2. It's going to double it. And then I'm going to print the state again, that value of x. Now that value of x has changed. That is 20 now. I've permanently changed the state of that object. I've changed that value of x from outside of that object entirely. So this object is carrying around with it a particular state that can be modified. That's the key point with objects. They have state. We've been using them just for their methods so far, but as we transition to this part of the course, each object can have state. It has some internal variables that can change. So for example, we've seen this before. One class that we've seen quite often is the string class. If we go to the definition of the string class, we're going to see that Scala actually just says we're going to use Java string class. So we're using Java string class, and if we look at that, we have some class named string. I'll talk about what a class is in a second. But we can actually see that character array that string class is based on. So string has an internal state containing its array of characters, and then we have a lot of methods attached to this class. If we want to ask, for example, the size of a string, somewhere in here we're going to have, oh, come on. This is supposed to be quicker. Is it length? Yeah. It was supposed to be quicker, but I want to show this point. Let's look up split. Here we go. All right, so the split method, this is a method defined in the string class. So we have this method which is going to look through that character array. It's going to look for each time that string that we're trying to split on appears, and then chop up that character array and return us a new array. Return us a new array of strings as its return type. Now this is the Java string class that Scala uses, so this is Java code. A little bit different syntax, but this is the return type, a string array, and then we get that as a Scala array of strings. So the string class has state, has its state. The most important thing for the string class is that array of characters is part of its state, and behavior, a lot of methods that we call on our strings, split, 2 uppercase, 2 lowercase, length, all the functionality we expect from a string, it's all defined in that string class. So what is a class if everything's an object? Why do we have classes, and what are classes? And fun fact, classes themselves are actually objects, but we don't have to go that deep. But every value in Scala is an object. Everything we work with is an object. And classes are going to help us create new objects. So when we have that object with state class, that doesn't get us much of what we want. So we have this object, it has state, it has behavior, but we can only have one of them ever. There can only be one object with state. You can import it in your classes, you can modify it like that, but there can only be one object with state. Now what if we have something like a string? We want to define what a string is, and then we want to create many, many instances of strings. We want many strings throughout our program, but we don't want to just define one object with one char array with the methods that we expect. Well, how are we going to have 2 strings in our program? We're going to get jammed up real quick on that one, and that's where classes come in. We're going to define classes which are going to be templates that we're going to use to create objects of the same type. So we write a class, and then we can make objects using the keyword new. We can say new, the name of our class, and that's going to create us a new instance of that class as an object. So now we can create a lot of objects with the same state variables and the same behavior, the same methods, but their states can vary independently. So now we can have 2 strings with different values, with different character arrays in our program at the same time, just by creating 2 string objects from the string class. That's what we want to be able to do. So here's our first class definition. We'll go through the parts of this. First, we're going to use the keyword class instead of object. We're defining a class. not just one single object. We want to define a class which we're going to use to create many objects. So we want to create an item class with a description and a price. So if we have some store, we don't just want one item. This is the one item that we have in this store. We want to create many different types of items based on the same class. So that's what we're after here. A lot of different items with a lot of different descriptions, a lot of different prices, but with similar state and behavior. So we're going to define the state and behavior just like we did the object. We want to know for our inventory purposes how many, and for accounting and everything, how many times was this particular item purchased. So how many times was a particular item purchased? We're going to store that as an int and initialize it to 0. We're going to say this is the internal state of an item in our store. And then we're going to define some behavior that depends on the state. So if somebody purchases this, we're going to have our point of sale software call the purchase method on this object that we create from the class. And that's going to increment the times purchased variable by 1. And if we want to change this to on sale, we have the manager in the back wants to put an item on sale. They're going to hit the on sale button on whatever they have. It's going to call the on sale method and decrease the price by 20%. So we can change that state from the behavior, from the methods. We can change the internal state of this object. So far that's pretty much the same as an object is a single object. Now when it becomes, the class-specific stuff is this new syntax up here. So when we create a new class, when we say new item, I want to create a new item using this class, which is a template to create objects. When I want a new item, a new object of type item, I'm going to call this special method that's defined up in the header of the class, which is called the class's constructor. I'm going to call the constructor method, and this is going to return a new instance, a new object of this type. The constructor can take any, the same idea as any method. It's going to take parameters. You have to call those parameters when you create a new instance. And here, the one big difference is we do need to use val and var if we want to specify if these are can vary or not. If we don't use val or var, it's going to effectively be a private variable. It's something that you won't have access to outside of the object. So something to be aware of there. For now, if you just do everything var in your constructors, you'll get away with that for now, at least. Maybe the whole course, possibly, if I'm being honest. And these constructor parameters will become part of the state of the object. So these are the same as if we had them down here with times purchased. When we put them in either spot, the difference is if we put them in the constructor, we'll put them in the constructor when we want them to vary between object to object. When we want the user to be able to define some of the state, for example, the description of a new item, we want the user to be able to say, I want a new item of this with this description and this price. And also when you want to initialize the state. So the price, we want some initial price that the user can specify when they create new items. I want to create an item with this description and this price, but the times purchased, you don't need your other code saying this has not been purchased before. Times purchased should always be initially 0, so that we're not going to give the option. We're just going to say that always starts at 0, so we can define that part of the state outside of the constructor. We can also add more code. When we create a new class, all the code outside of the methods will be executed. So if you need to do some initialization on your variables, you need to do some math and do some computation to be able to get that initial state, you can set that up outside of the methods right here. You don't have to just do variable declaration. All right, any questions to this point? I'm throwing quite a bit at you in this lecture. Any questions? You wanna call a function up here? No, that has to be, they're parameters. It's just like defining a regular method. All right, let's keep moving then. So let's see how to use this class. So that's how we define the class. We defined an item. It has a description. It has a price. It tracks the number of times it was purchased, and it has two methods for its behavior. Now let's use these things and see what we're going to do with that class. So now we're in another file, another part of our program, and we want to start using the item. We can't do much with the class itself, the item class, but we can create objects of type item. And objects, we're used to working with those. They have methods, they have variables. We can work with those. So to create a new instance of an item, a new object of type item, and we are creating our own types here. Like string is a type, it's defined by its class. We created a new class, we just made a new type in Scala, and we can specify that type as variables. We can specify that type in our parameters. We can have methods that return that type. Anything we can do with the built-in Scala types. We just created a brand new type, and we can do anything with those. We can create data structures with that type as a type parameter. We can have a list of type item with this brand new type. So we want to create instances of this type. We're going to say new, the keyword new, and then call the constructor, and the constructor method has the same name as the type we created. So new item, and then specify those two parameters in the constructor. So I want to create new cereal. I'm going to say this cereal costs $3, at least initially before it goes on sale. So I can do that by saying new item cereal 3.0, and now I can store that in a variable with the type of my brand new type item. I can create a variable type item, create a new item, store that item in this variable. And I'll do the same thing with milk. I want another new item of type milk that costs $2 and store that in a variable named milk. And that variable has the type item, that variable has the type of my brand new type item that we just created. And now we can start calling that behavior. We can start modifying the state, accessing the state, calling the behavior. Anything we could do with any other type, like strings, ints, arrays, lists, maps. We can start calling its methods. We can access its state and do what we need to do with these items. So cereal, we want to purchase it a few times, put it on sale. Once we call on sale, the price is going to change every time we purchase it. The times purchased variable is going to change. And we can also access these variables directly. If we just want to manually set the price of milk to $1.50, we can do that, and that's going to print out $1.50 when we call that. Let me make that a little more concrete. One quick change here. So notice that and we get the output we expect. I want to highlight these last two lines, printing the price of milk and cereal, and I have a quick method that accesses the description and price of an item. When we print these, we'll notice that milk and cereal, they each have a variable named price. And those two variables store different values. These two instances, these two objects of type item do not share any state. There's no shared state between these. So when I set the price of milk, milk.price, the price variable in the milk object, I can set that to 1.5. That does not affect the price of cereal. Cereal is still $2.40. After it was $3 and then went on sale, it's for 20% off. That price of cereal is not affected by the price of milk. So we created two completely different objects with their own state. And they both have a price variable, they both have a description variable, and they both have a times purchase variable that are accessed through the dot operator of those separate objects, and they work independently of each other. Every class will be passed by reference. This is a big topic. We'll talk about this at length, like all next week. It's obviously one of the bullet points, so we're going to spend a long time on it. It's one of the bullet points for this learning objective, but I want to at least introduce it today. Whenever you create a class, objects of that type are going to be passed by reference, and some of the types we've already seen, list, map, and array, these are all passed by reference. That means we don't create a copy of them when we call them as a method argument. When we call a method, use these as arguments, there's no copy made. We're actually giving it the entire object, and any changes made that that method makes to our object does reflect outside of that method. So we will see those changes because they're passing it by reference. As opposed to ints, if you pass an int into a method, there's actually a copy of that int made, so you can modify that parameter inside your method, and it's not going to affect anybody outside of your method. But actually those are vals, so you'll get an error that says you can't reassign it anyway, but you could, because those are going to be passed by value. But passed by reference, all of our classes are going to be passed by reference. So when we saw this example, oh no, this is a different one. We didn't see this one yet. But when we see this example, when we have a method that's going to increase the price of an item, it's returning unit, so it looks like it's not going to do anything. We have an item as a parameter, and we're going to say item.price increased by 25 cents. I want to make this a quarter more expensive. That change is reflected outside of this method. So when I say cereal is $3, and I call increase price, this variable cereal costs $3.25 now. Because when I called this method, I gave it my entire object. And I said, here, have the entire object. So this change is reflected out here. This variable item stores the same exact object as this variable cereal. And if I do this assignment, cereal2, just another variable of type item, equals cereal. Cereal and cereal2, these two variables store the same exact object. And any change I make to one, if I increase the price of cereal2, cereal now costs $3.50. Even though I never said, hey, cereal, increase your price, I used it in a method call. That increased the price, and cereal2 went in the same method. All of these, cereal2, cereal, and item, all referred at those times to the same cereal, that same item, that same object. So all of those price increases, those two price increases, are reflected in cereal. So the changes you make to an object will reflect everywhere that object exists. You have a question?
Yeah, so just a little lost because you can make changes to cereal and cereal too, right? But they're values, are they variables?
So these are cereal and cereal2 store values, and every value is an object in Scala. So those values are objects.
Okay.
Was that your question? Does that answer it?
Yeah, I think so.
So we'll talk about this at length next week, but just real quick, just trying to guess what we're talking about here. Cereal and cereal2 actually store a reference to that item that was created, which is kind of equivalent to a memory address. It knows where in memory to find that item, and then it goes to that place in memory and then makes that modification. So all of these variables are actually storing that memory address or that reference and then referring to the same object at the same spot in memory.
That's better.
Okay. A few kind of random things, especially if you're doing the physics engine homework, you'll see a few of these two things. So I just want to give a few kind of randomish things that we can do with classes. You'll see this in the physics vector class, that inside the parameter list, I have these equals some value. These are default values. You can do these in any method in Scala. You can define default values. And if any of these parameters are not present in the argument list, they'll be set to their default values. And they will be in order. So if I say new physics vector of -6, -6, that's going to map to the first value, x, and then y and z, the next two, we don't have 3 arguments, we only have 1. So y and z are going to be set to 0. If I just do new physics vector, all 3 are 0, or I can specify all 3 and manually set all 3 of those. So if you want to use default values, it can really help with some code. In the physics engine homework, there are default values on the physics vector. So when you see that, don't panic. That just means you can say new physics vector, open paren, close paren, and you're going to get a new physics vector at the origin. You're going to get that 0, 0, 0 physics vector. Another thing here is you can have this, this notation. We'll talk about what this means when we get to object-oriented programming, when we get to the next learning objective. For now, just suffice that this toString in this format, this method can exist. If you do override def toString of type string equals whatever, inside the body you can define how that string is printed when you print it to the screen, or really whenever you call the toString method, which is implicitly called by Scala in the printline method. The printline method is going to call our toString. So if we want this to display, I want a physics vector to display how a physics vector should, with parentheses in this format. We can do that with the toString method. So whenever you create a class and you want things to be printed in a particular format, hit it with that toString method, and then it's going to give you some better visuals when things are printed to the screen if you're reading these values when they're printed to the screen manually. So toString helps us with that. In references, it's been a while since I talked about references, 2 slides, so let's remind you again, especially in physics engine. I have this warning in the homework as well, but it's worth repeating many, many times because this is a real headache causer if you do something like this. Plus it shows that you don't understand references if you do something like this. So let's make sure we have this down. If you're starting the homework early especially, you have to remember the previous location of an object. Part of the homework, if you haven't read it, is there's an object with some velocity, and you need to update its location based on that velocity. So you move it, if it's moving in this direction, you move it there based on what your delta time is, and update the location of that velocity. But you also have to remember the previous location. So as you're updating, you have to remember the previous location, and also update the location, the new location that you're moving to. If you do previous location equals the current location, which we'd all be tempted to do, you'd say, oh, the previous location is going to be the current location, and then update the current location to be, with that delta time and velocity factored in, update the new location. Well, guess what? This was an assignment by reference. So when you update the new location based on dt and velocity, you actually updated the previous location too. And now both locations refer to the same physics vector, so they're both going to change, and now your previous location is going to be your new location. You're going to have some really hard to detect bugs if that happens. If it's not something that you can eyeball and detect and figure out what's going on, it's going to be a very hard one to debug. Passed by reference, these are objects that we created, the physics vector object. This is an assignment by reference. These 2 variables refer to the same object. Changes made to one will affect the other. Just a quick note, because we did use classes. We have used classes. We've created instances of these classes. But you might say, you should be saying, wait, how come we never used this keyword new before? We've created new instances of the list class, objects of type list. Why didn't we ever use the new operator before? How come we just said list of whatever? The way these types are set up, they're set up so we don't need the new keyword, and we're calling a different constructor. It's just some more setup, something we probably won't do in our classes. I have no intention to. It doesn't really help with understanding the concepts. But it's more of a Scala-specific thing. What these classes have is called a companion object with an apply method, and what this implicitly does is called the apply method, which they use as a different constructor, and they use that when there needs to be a lot of setup and initialization to the object. But suffice for our purposes, some classes you don't need to use the word new, but any class that we write, any class that you write, we're going to use the keyword new. We're not going to use the companion object with the apply method. Unless you want to, if you want to in your homeworks and stuff, I'm not going to stop you. But it's not something I'm going to cover in class. It's just one more thing that we'd have to know. But suffice to say, some of these classes, you don't need to use the keyword new. And I got to talk about access modifiers, mostly for those of you coming from Java saying, where are all the access modifiers? I got to talk about this or else some people are just going to get mad. So access modifiers determine who can and cannot access certain state and behavior of an object or a class, if we're using static in Java specifically. And these are a bit controversial. Different communities for different languages, across languages, they can't really agree on what the proper use of access modifiers is. This is quite controversial. If you're coming from Java and you learn from a Java instructor, they're going to tell you access modifiers, you have to always have them, and they're the most important thing ever. If you've learned in a different language, it might not be stressed so much. If you took 115 here with Python and JavaScript, you haven't heard of access modifiers at all. So let's talk about these, what they are a little bit. In Java, we have 4 different access modifiers which say who can and can't control it, a particular value. Public, everybody can access it. Private, only that object can access its state, those state and behavior. Protected, meaning only subclasses or classes in the same package can access it. And then package private, which is the default, which means only objects in the same package can access those values. And the difference between package private and protected, the extending classes in the inheritance tree can't access the package private values. In Scala, we have private, protected, and public. The default is public, and you won't see me use an access modifier all semester. Everything's going to be public and open, and that's kind of the Scala way. Scala's happy with that, the community, I should say. Python and JavaScript, there were no access modifiers at all. And this is what I mean when it's controversial. The Java community is all about these things. Python and JavaScript, they're just like, we're not even adding it to our language. It's not even in the language definition. You can't use access modifiers in these languages. So if somebody's telling you access modifiers are everything, well, they probably haven't seen Python or JavaScript, or they probably hate those languages. They probably don't like them. Everything's public. In Java, there's a workaround where you can kind of simulate private variables. And in Python, there are ways developers kind of agree to mark their variables as private, mostly just to tell other people, hey, you shouldn't modify those, you shouldn't be accessing these. And some IDEs will respect that and not even show them in the autocomplete and things like that. But Scala, we're just going to use everything public. But here is some Java code. If you came from Java, you saw way too much code like this, where they say Java and C++. These communities say every state variable should be private. Never give anyone access to your state variables ever. Never give them direct access. Instead, use getters and setters, or accessors and mutators, and every change in state has to go through one of these methods, has to go through a method to be able to access that variable. If you've taken any class in Java, they've done this. When I teach in Java, I do this. It's the Java way. This is how you do it. Scala, to get around this, for those really curious, Scala, to get around this, our state variables are public, but we can add the functionality of getters and setters using some special syntax. We can add the getter and setter method, and then the syntax for that to call the getter or setter is still just, in this case, .x, and then the setter getter is called through some special syntax. So if we want to add, the reason Java does this is, well, what if we don't what if there's certain values that'll break x? What if x can't be negative, and we decide that later on down the road? Well, then we just add it to our setter, say if the input x is negative, don't set our internal state to a negative value because that'll break everything. With Scala, you would write that setter later if you decide that you need to add that functionality, and when somebody uses the same syntax to just access x or modify x, it'll go through the setter or getter. So just a quick side note, but that's why we won't talk about access modifiers in this class. Suffice to know that they do exist, and I wanted to do one more quick example. Did I go through that already? I guess I went through them in the slides. Confirm that that's 350. Does anybody have questions? I know I threw quite a bit at you. You might still just be digesting everything that just happened. Anyone have a question that would help to? Yes, thank you.
Create the item serial with a value to it, and then you choose to create a new item, also called serial.
Yeah, so if I create a new item, also with the name serial, these are actually two completely different items. So when I run this, and at the end here, I want to print. So I created a new item, also called serial, but stored it in a different variable. If I run this, I'm going to get serial is going to be $3.50 still, but serial 3 is only going to be $3. Every time you use the keyword new, you are creating a brand new object of that type. So Scala didn't care that these variables had the same value. It's not thinking that far ahead. It's just doing the very simple, oh, my user asked for a new item, going to create a new item and set those variables in the constructor equal to these values. So we get two completely different items. Even though to us as humans they look the same, the Scala will not treat them that way. These are two brand new, completely different objects with different state. Yes?
So should we create the new objects with val or var? And is there like a difference between that?
Yes, so the question is, should we create new objects with val or var? Typically val is fine. I mean, it usually doesn't hurt to use var. We're not going to get into things where using var instead of val is really going to hurt us. But we can use val in most cases with our objects. So, and this is an important point, serial is storing a reference to this item as a val. Now serial, its state changes. A lot changes with serial, but the values with this object, but the value serial always stores that reference, and that reference does not change. So we're using val here on things that do change their state. The internal state of these things change all the time, but we're using val because those references, we're never changing those references. This is different than a list. If you create a list, you want to use var if you're ever changing that list, because that reference does change. We're actually referring to a brand new list whenever we append a value to it. So we do want var when we're using our data structures, but we can use val when we're creating objects and then modifying the state of those objects. We can use val in those cases. Yes?
Can we write the constructor as a separate function?
Yes, so the question, can you write the constructor as a separate function? That's where you do the companion object and the apply method. It's not something we're going to get into. We'll just have very simple constructors with very simple initialization. But that's how you would do that, and that's why those other classes do that. Yes?
So when you want to copy an object to a new variable without the reference history, you want to use that new keyword, the item, with the last.
When you
Like
want to copy, sorry, what was it?
when you want to copy the object to a new variable, but you don't want to have the reference history.
Yes, yeah, that's when you would use new. So if you want to copy, if you have an object and you want to copy it into a new variable and not copy it by reference, you'd have to use the new keyword and create a new object of that type. So say I didn't want this, this issue of serial and serial 2, maybe I don't want that behavior where they're referring to the same object. I would do new item. One way to do it anyway, serial dot description, serial dot price. So I'm going to get a copy that doesn't refer to the same object. Now these will modify separately. They'll be independent of each other. Oh, I forgot I can't zoom in on this. Damn it. So if we look at, serial 3. So if we look at serial and serial 2, this is called the debugger. I'll talk about this. We'll explore this a little bit more next week. Debugger is a very useful tool. It can save you hours and hours of time, of debugging time. But with this, we can see serial is referring to a type item at this reference 587. Serial 2 is referring to the same thing with the same state, all the same values. But if we look at serial 3, that's referring to the reference 589. These are different objects, not the same object. The other two are referring to the same exact object instead of referring to a different one. Any other questions? Have a good weekend. See you Monday.